Hey everyone, and welcome. Today we're going to dig into an idea that could completely flip the script on AI language models. What if instead of just predicting the next word, AI actually learned how to fix what's already on the page? It's a fundamental shift in how we think about AI, and it might just be the key to unlocking that next level. Let's get into it.
So the AI that's behind all the tools we use every single day, it's built on one really powerful idea. Just predict the next word. And look, it's been amazingly effective, right? But what if that core strength is also its biggest weakness? What if the real secret to making AI smarter isn't about getting the first guess right, but getting really good at correcting its own mistakes?
All right, so to figure out where we're going, we first have to get a really clear picture of the limitations of where we are right now. Let's peel back the curtain on this hidden flaw that's baked into today's most popular AI models.
Okay, so the fancy technical term for this is autoregressive. But let's just forget the jargon. Here's a super simple way to think about it. Imagine you're an author, but your keyboard is broken. You can only type forward, one single word at a time. The backspace key? Nope, doesn't exist. Once a word is down, it is permanent. That's it. And this forward-only process, it creates some serious tunnel vision.
In this example, oh man, it just nails the problem perfectly. When you or I do simple addition, where do we start? On the right? We do 3 plus 6, get 9, and move left. But in autoregressive AI, it's forced to go left to right. It has to guess the first digit, 5 in this case, without having any clue what 3 plus 6 is going to be. It's trying to solve the problem in literally the hardest way possible, all because of this built-in bias.
And you know, it's not just about math. This left-to-right blind spot absolutely trips up AI in all sorts of reasoning tasks. I mean, think about a Sudoku puzzle. You can't just guess the top left square and hope for the best. You have to see the whole board. It also explains this really weird thing called the reversal curse, where an AI can learn Dmitry von Werdow wrote this article, but then completely fail if you ask who wrote this article. It just hasn't learned the concept backwards. And that is why AI can feel so rigid sometimes, almost nonsensical.
So, okay, if this forward-only predictive way of doing things has these major flaws, what's the alternative? Well, get ready for a completely different philosophy for generating text: diffusion models. Instead of that writer who can never go back, I want you to picture a sculptor. A sculptor doesn't start with the tip of the nose, right? They start with a big, meaningless block of stone, or in our case, a page of complete gibberish, just random words. Then, little by little, they refine it. They chip away at the noise, they correct the errors, until a perfect sentence emerges from the chaos. That right there is the core idea of a diffusion model.
So how in the world do you train an AI to be a sculptor? It's actually pretty brilliant. You start by showing it a perfect sentence. Then you just destroy it. You systematically corrupt it, adding more and more random noise until it's total nonsense. And the AI's entire job? It's to learn how to perfectly undo that damage, to take that absolute mess and restore it back to its original, perfect state.
Now here's the thing, not all diffusion models are the same. We're going to zoom in on one specific kind that a lot of researchers think holds the real key to the future.
So one type of diffusion model kind of works like a game of Mad Libs. You know, it just fills in the blanks in a sentence. That's called masked diffusion. And it's okay, but it's still sort of a form of predicting. The real breakthrough, the one we're talking about, is called uniform diffusion. With this one, the model doesn't fill in blanks. It takes a complete but really messy first draft and fixes it. This teaches the AI a fundamentally different and way more powerful skill: self-correction. And this quote from our source material just says it all. The goal completely shifts. It's not about guessing what's missing anymore. It's about actively spotting what's wrong and figuring out how to fix it. It's the difference between being a good guesser and being a great editor.
So here's the key takeaway. This whole training process basically bakes the skill of editing right into the AI's DNA. From the moment it starts learning, it's mastering the art of refinement and improvement. It's not just spitting out text, it's learning how to make it better, again and again. And this could lead to an AI that is so much more coherent, creative, and just solid.
But wait, we can push this idea even further. I mean, if we want to create a truly expert editor, we have to give it smarter problems to solve while it's training.
Just think about it for a second. Replacing a word with a totally random one? That's a pretty easy mistake to spot. So to make the AI smarter, researchers are making the noise smarter. They've gone from using completely random words to using more common words to using words that might actually make sense in the sentence, and now, get this, even using another AI just to create subtle, believable mistakes for the main AI to practice on.
Okay, so this brings up a really important question. When the AI is looking at this page full of messy text, how does it decide which word to fix right now and what exactly to change it to?
Well, the whole process really breaks down into two key decisions. First, you have the what. For every messy word, the AI predicts what the most likely correct word should be. And second, there's the when. It basically estimates how likely the current word is already correct. So if a word looks good, it leaves it alone for now. But if a word looks really out of place, that's the one it targets for a change. It's this two-part system that lets the model strategically revise the text step by step.
So if we put all of these pieces together, what does this actually mean for the future of AI? And what are the big hurdles we still need to get over?
Okay, one massive advantage here is data efficiency. Because you're adding random noise every time, each training example is technically unique. This means the model can learn from the same top-tier data over and over again without just memorizing it. And that means we can train a more powerful model using a smaller, more carefully selected data set. We're talking quality over quantity, which could lead to much, much higher quality AI.
But of course, we're not there yet. There's a ton of work to do. Researchers are still trying to find that perfect Goldilocks way to add and remove noise. And right now, these models are fantastic at revising, but they can't easily add or delete words, let alone do complex stuff like swapping whole phrases around. Solving these challenges, well, that's the next big frontier.
And as Dmitry von Ritta, the author of our source material, puts it so well, these are some really big claims about the future. The ideas are super compelling, for sure, but now the real work starts. Researchers have to go out and actually gather the evidence to turn all this amazing potential into reality.
And that really leaves us with this one big thought to chew on. For years, we've been obsessed with this idea that the path to smarter AI is all about better prediction. But maybe, just maybe, the true path forward lies in building an AI that has mastered the art of looking at what's already there, spotting the flaws, and just making it better.
Thanks so much for joining me.